Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video, we write C++ code solution to LeetCode problem number 8, string to integer. So before we begin, it is a request to please subscribe to my channel. So this is the question, take a minute and give this a reading. Okay. So you basically have to implement your own version of atoi. Atoi is an inbuilt function. If you have worked with C and C++, it takes a char pointer, a string, and returns the integer that is inside it. So if you want to check more about it, so you can have a man atoi, okay, and see it will give you, it is included in stdlib.h, converts the initial portion of the string pointed by str to int representation. Okay. In this question, you have to implement your own version of atoi, where you are given a string and you have to extract and return an int value that is inside that string. Okay. The rules for the input that you need to follow are given here in 1, 2, 3, 4 bullet points. The first one is you have to ignore any leading white space. Second one is you have to take care of the sign. So there can be a minus sign or a plus sign, or there is no sign. So if there is no sign, you have to assume the number is positive. Okay. Then you have to read the integer by skipping all the leading zeros. So possibility of leading zeros until a non-digit character is reached. Okay. So if you have a string example, something like this, say 2, 3, 4, 5, and then hello. So your method should return 2, 3, 4, 5 because this is the integer that is found at the front, and then you ignore hello, the remaining characters. Okay. And that's why it says until a non-digit character is encountered or the end of the string is reached. If no digits were read, the return value is 0. Okay. Then the critical point is that you have to take care that it should be between the limits for a 32-bit integer. That is, 32-bit signed integer is within minus 2 to the power 31, the negative side, the maximum negative value, 2 to the power 31 minus 1, which is the maximum positive value. So if the integer in this string that we are extracting is less than the minimum value, we return the minimum value. If it is greater than the maximum value, we return the maximum value. Okay. The first thing that you need to take care is, so I can list possible cases here. Okay, one of this is this returns 245. Okay. All right. The first thing is you need to ignore leading white space. Okay. So I will start with my I at 0, the leftmost index, and I'll say int L is my s dot length, the length of the string, and taking this in a separate variable because I will be using s dot length a lot. Okay. So as long as this index is valid while I less than L and I have a white space, so I can use the inbuilt space method. It takes a character, returns true if it is a white space. So I will ignore all white spaces starting from index 0. I do I plus plus. Okay. So if after ignoring all the white spaces, I am out of characters, if no more characters, that is if I equal to s dot length, okay, then you return 0. And this is the case something like this. Okay, there were only blanks, there were only white spaces that you skipped. The entire string was a blank string and your index reached to the end of the string, it became equal to the length, so you have to return 0. Okay, so ignore any leading white space. The next part is to check for sign, so check for valid sign. So if the next character and the program control reaches here only if there are any more characters left. If there were no more characters left after this loop, then we return 0. Okay, so if at this index, okay, I have a negative sign, so my number is negative, so let me just take bool negative is false, and I will set negative to true because this is a negative value, and I move to the next character. Else if this sign that I expect is plus, okay, then negative remains false, I just move on to the next character. Okay, so move on to the next character. Okay, move on to the next character. Okay, else if, so the valid signs are plus and minus. If there is no plus, there is no minus, we don't expect any sign, we expect a digit. So if there is no plus, there is no minus, we want a digit, and if there is no digit, then it is an invalid string. So if not is digit, okay, is digit again is an inbuilt method. S of I If s of I is not a digit, we return 0. Okay, because after skipping the leading white spaces, we did not get a sign that we were expecting, and we encountered a non-digit character. Okay, so in this case, your string could be white spaces and non-digit character, which is E and 23. Okay, so you got E first. The valid case for a plus would be something like this, and a valid case for a negative would be something like this. Okay, now again, after you check for your signs and if no more characters, okay, we return 0. Okay, all right, then we check for leading zeros by skipping the leading zeros. So skip the leading zeros. So this loop will be very similar to this, that we are trying to skip all characters that are zeros. So while I less than L and S of I is a character 0, we do I plus plus. And again, after you skip all the zeros, if no more characters left, you return 0. Okay, so this could be a case, okay, where we have a lot of white spaces that we skipped. We had a plus sign that we were able to absorb here, and then we have just zeros. So you return 0. Okay, now we come to the part where you extract numbers and return the int value. Okay, all right. So I will take my value equal to 0, in which I'm going to build my value. I'm going to say the same thing while I is less than L, and I have digits continuously. Okay, and my ith character is a digit. So extract the integer value of digit as s of I minus 0. Okay, very standard way to extract the corresponding int value from a character that contains a digit. Okay, this is subtracting ASCII values. So if s of I is character 2, okay, within single inverted quotes, character 2. So character 2 has ASCII value 50, 0 has 48. Character 2 minus character 0 basically is 50 minus 48 gives you 2. Okay, all right, get the corresponding digit for this char. All right, so if our value was negative that we set here, we do value equal to value into 10. Okay, plus since we are building a negative value, we say minus digit. Okay, else if this is not a value, no, else if it is not a negative value, we simply say plus digit. Okay, if this is a negative value, okay, else if this is a positive value. Okay, and eventually you return value. Okay, all right, so this loop will keep extracting digits, and the moment there is a non-digit character, the loop breaks. So I need to do I plus plus as well. The loop breaks when there is a non-digit character, and we return the eventual value. So let me just test this. Okay, so 42, we get 42. For this case, we skip all the leading white space that we are skipping here. Leading white space, all right, then we absorb the sign, skip leading zeros, and then for minus 42, so we get minus 42. Similarly, in this case, since there are no leading white spaces, there are no leading zeros, we start here. Okay, and we keep building the value till we have digits. So moment we have C, which is a non-digit character, we stop. So we get 1337, which we build into our value, which is positive because this flag never changed. Okay, it stayed false. Then we have 0 minus 1, this will give us 0 because this is the only digit we got. Okay, and the moment we find a non-digit character, we stop. Okay, and in this case, we did not have leading white spaces. Okay, we were expecting a sign which we did not get. We got W, which is not what we expect, so we simply return 0. So our test cases are all fine. Okay, the cases finally we need to consider are now these underflow and overflow. Okay, so basically what happens, okay, check if val is within limits. Okay, so now how do we check for overflow and underflow? So the maximum integer value we have is 2 to the power 31 minus 1, and minimum integer value that we have is minus 2 to the power 31, right? This is it, right? Okay, so if you want to check these values, these are stored in int min and int max. So I can simply do int min is int min, and L, this is within C limits, which is already included. And I also have int max max max. Okay, int min int max, and let me just return 0 for now. So we will get int min and int max values, but we'll not get the right result. So let me just test for output. Okay, so int min is this part and int max is this part. Let me just add a space. Okay, just testing this. Okay, so this is your int min and this is your int max. Okay, so this value is basically minus 2 to the power 31, and this value is basically 2 to the power 31 minus 1. Okay, max and min limits. Okay, commenting this out. Okay, and testing again. All right, so these are our limits. All right, so if you consider this as the entire set of integers between these two limits, so if I have my int min here, okay, and I have my int max here, okay, and assuming this line is all the values between these two limits, so int min, again let me write it, is minus 2147 483 648, and int max is 2147 483 647. Okay, the magnitude of int min minus 1 is what int max is. Okay, so we need to check if the value that we are creating, okay, is within these limits or not, and if there is a possibility, if it crosses, if it goes beyond int max, okay, or it goes less than int. Okay, so I will take two variables, min and max. Okay, what are these values? So min is basically this very int min value except the last digit. So we remove the last digit from this int min, this minimum integer value that can be stored, and store it in this variable min. So this comes out to be minus 2147 483 64. Okay, we removed 8 from this int min. And similarly for the case for max, we remove this digit 7 from int max to store it in this variable max. So this comes out to be 2147 48364. So let me write it like this, equal to. So your min basically is equal to int min integer division by 10, and your max is similarly int max integer division by 10. Okay, removing the last digit. Now why? The idea is we are building this value digit by digit. Okay, so if the value that we are building goes beyond these two, then we can check for our border cases. For example, if my value, okay, is right now say 2147 483 and 88. Okay, so my value right now is greater than my max. 2147 483 88. This is 64, this is 88. That's what the digits are saying. Okay, so this is the value that I have been able to extract till now using the digits from my string, and there is a possibility of another digit that I can extract from the string. So now whatever digit I add to this value, okay, it will definitely cross int max. Okay, because this magnitude, this value is already greater than max, and when I add one more digit to this value here, be it any digit, it will be greater than int max, right? So if value that you are creating at any iteration goes greater than max, okay, then you cannot add any more digit to it. Okay, so you return int max. Okay, all right, this variable that is storing the generated value that we are getting from extracting the digits crosses max, and there is one more digit to add. We cannot add that because adding one more digit to this value will cross int max. Okay, The other possibility is if value equal to max. Okay, that is if my value equal to this max, which is 2147,483,64. So if my value equal to max, this very value, what digits can I add to it so that it does not cross int max? Int max has a 7 appended to it. So the digit that I can append to this max value is 0 to 7 only. Okay, so 2147,483,64, you can append a digit 0, digit 1, digit 2, digit 3, digit 4, digit 5, digit 6 and digit 7. Okay, so if value equal to max and digit that you are supposed to append is greater than 7, that is not possible, because in that case it would be 648 and 649, which is not allowed. So in that case also you return int max. Okay, all right, and we are doing this because the value that we are generating in our code here, we are generating it by, okay, digit by digit, appending digit to this current value. Okay, so if we have another digit coming, we can take care of the fact if that digit can be appended to that current value or not within the limits, right? So that's why we take max equal to this int max, removing the units digit, one last digit. Okay, so if the value that we are generating goes greater than max, then we cannot add any digit at all. Okay, and if the value we are generating equals max, the only possible digits we can add are 0 to 7. So if the next digit that is to be added is greater than 7, we return int max, which goes into the code as if value is greater than max. Okay, and the digit that you are supposed to append has not been appended yet, we are doing it in the next step. So before we append the digit and value has already crossed max, which is int max by 10. Okay, so you simply return int max. Okay, other possibility is if value equal to max and the digit that you are supposed to append is greater than 7, we are not allowed to do that, cannot do that, it will go overflow, we return int max. So handle overflow. Okay, very similar is the idea for min. Okay, so you can guess if we have value that we are generating less than min already, that is if we have minus 2147,483 and 88. Now this value is already less than min and we have one more digit to append to this. This is not possible because if we append any more digit here, be it 0, 1, 2, 3, any digit, it will cross this int min limit. Okay, and so that is not allowed. So again, if value is less than min and we have one more digit on the way, so we return int min. Okay, and similarly if value is equal to min, we can take the border case as well. Value is min, that is value is equal to this value. Okay, so the only digits that you can append are 0 to 8. Okay, because minus 2147,483,64, 8 is the least value, the negative limit. So you can add 0, 1, 2, 3, 4, 5, 6, 7, 8. The moment you add something greater than 8, which is basically just 9, this is not possible. So if value is equal to min and the digit you are adding is greater than 8, we return int min again, just as the case we did with int max. Okay, so we handled overflow. Similarly, we handle underflow. Okay, if value is less than min, okay, we return int min. Oh, let me take min as well. So int min by 10, we return int min, and if value equal to min and digit greater than 8, we return int min again. Otherwise, we keep appending the digit to our current value and we keep incrementing I, eventually returning the value. Okay, this should be your final code, so let me just test it first. Okay, submitting this. Okay, beats 100%. All right, memory is good as well. Okay, the key thing here is that you understand that we are developing our value digit by digit. So the fact that we can append another digit or not is what we check by removing one last digit from both int min and int max. Okay, we get these max and min values, and then we check if another digit can be appended or not, and that's why the check happens before we append the digit. Okay, because if this iteration is running, we got a digit and this condition is true, it means we have one more digit to add, which is not possible if one of these conditions is true. Okay, both for a case of overflow or underflow. All right. Okay, so this was the solution to this problem, and I hope this was helpful and you like this video. If there is any doubt, there is a part you do not understand, please let me know in the comments. I always try to answer all your comments, and you can always let me know if there is a question you want to solve or if there is a concept you want to discuss. So please like this video, subscribe to my channel, and thank you.